Hi everyone, this is the Nordic Venture Show, your guide to the exciting world of Nordic startups and venture capital. In today's episode, we're exploring a startup called SemiQon.
Hey everyone, welcome back to the Deep Dive. We know you're here because you want to understand what's next and you want to understand it quickly. Today, we're diving headfirst into the world of quantum computing. Specifically, a company out of Finland called SemiQon.
Yeah, they've been making some waves recently.
And for this deep dive, we've pulled everything we could from their website, their big ideas, their tech, their recent moves, really trying to get a feel for how they're approaching this whole quantum computing thing. The mission, I guess you could say, is to understand how SemiQon is tackling this massive problem. How to build quantum computers that are not only powerful, but, and maybe even more importantly, affordable, able to be scaled up, and sustainable.
All big challenges for sure.
So right off the bat, what stands out to you about SemiQon?
Well, one thing that really jumps out is just how direct and ambitious they are. They flat out say, we want to power the scale up of quantum computers with silicon-based quantum processors.
Okay, so they're not messing around.
Not at all. And they talk about enabling the million-qubit era, which is just, that's a huge number. It shows you they're thinking big, thinking long-term, aiming for truly massive quantum computers.
So not just little lab experiments.
No, definitely not. And here's the key. Affordability and sustainability are right there in their core vision from the very beginning. They get it.
Yeah, it makes sense. It's one thing to build a super powerful quantum computer in a lab, but if it costs a fortune to run or it's just too complex to scale up, then what's the point, right? It needs to be practical.
Exactly. They're not just chasing headlines. They're trying to build something that can actually be used and have an impact.
And they're addressing this right at the core. With the quantum processors themselves, they're developing silicon-based quantum processors, which I guess you could also call quantum integrated circuits. These are basically the brains of these future computers.
Yeah.
Now, for our listeners, why is this silicon focus such a big deal?
This is where it gets really smart, strategically speaking. They're essentially tapping into the massive, well-established infrastructure of the semiconductor industry. We've got decades of research, development, and expertise in silicon. By using these standard and, importantly, affordable materials, along with existing tools and manufacturing processes, they're setting themselves up for a huge cost advantage and a much smoother path to mass production compared to, say, more exotic materials.
Right, so they're not starting from scratch with some entirely new manufacturing process.
Exactly.
They're trying to integrate quantum computing into something we already know how to build and scale, which makes a lot of sense.
Yeah, and this ties directly into what they see as the biggest hurdle in quantum right now, the ability to actually scale these systems up.
Which they're very upfront about.
Yeah.
They say the biggest challenge slowing down the progress of the quantum industry is the scale-up of quantum computers. So that's their target.
Precisely. It's not just about building one amazing prototype. It's about being able to produce productized and affordable, high-quality, silicon-based processors that can actually be deployed, on a global scale. They want to democratize quantum computing, bring it out of the labs and into wider use.
Ambitious, to say the least. And a big part of their strategy seems to be their focus, as they put it, on building technology meant for cryogenic use. Now, for folks who maybe have trouble keeping their laptop from overheating, can you explain why extreme cold is so essential in quantum computing and how SemiQon is dealing with it?
Sure. So to get these quantum computers to work, especially the type that SemiQon is building, which are based on silicon quantum dots and something called spin qubits, you need incredibly low temperatures, like really, really cold. We're talking a few Kelvin, which is basically just a hair above absolute zero.
Wow, so colder than space.
Colder than pretty much anywhere you'll find naturally, yeah.
And why is that? Why so cold?
It's all about maintaining these super delicate quantum states that make these computers able to do their calculations. At those super low temperatures, everything kind of slows down, and you can control these quantum bits, these qubits, much more precisely.
I see. So it's not just about keeping the hardware from melting. It's really about creating the right environment for the quantum mechanics to actually work.
Exactly. And what's interesting about SemiQon is their specialization in quantum-optimized CMOS devices, which are basically electronic components designed specifically for these super cold conditions. They're really focusing on this cryogenic aspect, which is pretty smart because it allows them to build up unique expertise and intellectual property in an area that, maybe other companies are overlooking. And they even hint that some of what they're learning could be applied to other quantum computing approaches down the line.
So they're not just making qubits that can work in this deep freeze.
Yeah.
They're engineering all the complex electronics needed to control those qubits within that same extreme environment.
That's right.
And this is where they make a pretty bold claim. They say their chips are 100 times more densely packed and operated at 100 times higher temperature than competing modalities.
Yeah, that's a big difference.
It's a huge difference. How are they pulling that off?
Again, it comes down to their silicon-based approach and their expertise in something called cryogenic CMOS electronics. Essentially, they're building the electronics that control the qubits using the same basic materials and processes as the qubits themselves.
Okay, so everything is optimized for this ultra-cold environment from the ground up.
Exactly. And that allows them to pack more qubits into a smaller space and potentially operate at a slightly higher temperature, still very cold, of course, but warmer compared to other methods, all while still using those affordable standard semiconductor manufacturing processes, which keeps costs down. This is a potential game changer for achieving the scale needed for really complex quantum computing.
And potentially a big win for energy efficiency as well, right?
Yeah.
Less power needed to keep things so incredibly cold. So let's talk more about this cryogenic CMOS electronics, or cryo-CMOS, because it sounds like the key to their whole scaling strategy. What exactly makes this so essential?
Okay, so imagine you have these qubits that need to be near absolute zero. But traditionally, you would control and measure them using electronics that are sitting outside the cryostat at room temperature.
Okay, so you have this incredibly cold environment for the qubits, and then this whole separate system at room temperature trying to talk to them.
Exactly. And that's a problem for a few reasons. First, running tons of wires into a cryostat, which is basically a high-tech refrigerator, is really complex and limits how many qubits you can actually control. Second, it's just not very efficient. You're constantly fighting against the temperature difference, which wastes energy and makes it harder to keep everything cold enough.
So it's like trying to shout to someone across a vast freezing canyon.
Kind of, yeah. And this is where cryogenic on-chip multiplexing comes in. SemiQon sees this as the only realistic way to develop, optimize, and really scale up these silicon-based quantum processors.
Okay, so instead of this tangled mess of wires going into the cold chamber, they want to put more of the control and communication functions right there on the same chip as the qubits, all operating at the same temperature.
Exactly.
And cryo-CMOS is the technology that makes that possible.
Yes. Cryogenic CMOS electronics is the key to achieving this multiplexing, this control and readout of the qubits, all on the chip and all at those extremely low temperatures. And what's really neat is that they're using essentially the same manufacturing process to make both the qubits and the CMOS circuits on the same silicon chip. This close integration means very low noise, which is essential for keeping those quantum states stable and making sure the calculations are accurate.
So less interference equals better, more reliable performance.
Got it. And their goals here are pretty ambitious. They want to scale these cryo-CMOS multiplexers to be able to manage hundreds of spin qubit devices on a few square millimeters of silicon. That's an incredible amount of processing power in a tiny space. Yeah, and they're even looking at using machine learning to automate the analysis of data from these large arrays of qubits, all within a single cooldown cycle. So they're not just focused on building the hardware, but also on developing the tools and methods to actually use it effectively.
That's smart. So we touched on speed and cost a bit earlier. How does their location and, well, their origins as a company play into their ability to innovate quickly and cost effectively?
So they're based at Micronova in Espoo, Finland, which is a big plus. This is a state-of-the-art research facility with a pilot line fabrication plant.
So their own MIDI factory, basically.
Pretty much, yeah. And this gives them direct access to the whole design to manufacturing cycle. They can test out new designs, get feedback, and make changes incredibly quickly compared to companies that have to rely on outside fabrication facilities. And that faster development cycle, of course, translates into lower costs overall.
So being able to prototype and do small-scale production in-house gives them a lot of agility.
Definitely. And they're not doing all this in a vacuum either. They've got collaborations going with universities and private sector partners.
Right, so they're tapping into a wider pool of expertise and getting valuable feedback.
Exactly. Plus, they spun out of VTT Technical Research Center of Finland, so they've got these deep connections within the Finnish quantum and semiconductor ecosystems, including this new Nova facility that's coming online soon. It's a great example of how a strong research community can foster innovation.
Absolutely. Now, let's get into what seems like a pretty major breakthrough for them, their cryo-CMOS transistor. This sounds like a fundamental advancement. What is it, and why is it such a big deal?
This is potentially a game changer, yeah. SemiQon has announced what they claim is the world's first transistor specifically designed and optimized to function efficiently in cryogenic temperatures. Up until now, people have mostly been using regular, off-the-shelf transistors designed for room temperature, even inside the cryostat.
Okay, so like using a regular screwdriver to work on something that's frozen solid, it might kind of work, but it's not ideal.
Yeah, a good analogy. And the problem is those regular transistors, they just don't perform very well at those ultra-low temperatures. They use a lot of power and generate a lot of heat, which is a big problem when you're trying to keep things super cold.
Right, because any extra heat makes it harder to maintain that cryogenic environment, which is crucial for the qubits.
Exactly. So what SemiQon has done is create a transistor that's designed from the ground up to work efficiently at these incredibly low temperatures, specifically at 1 Kelvin and even lower. And the performance improvements are pretty amazing. These cryo-CMOS transistors use just 0.1% of the power and dissipate 1,000 times less heat compared to those regular transistors being used in cryogenic setups.
Wow, that's a massive difference. So not only do these transistors perform better in the cold, but they also make the whole system more energy efficient and easier to keep at those extreme temperatures. And the fact that this allows them to build advanced CMO circuits directly onto the chip with the qubits is a huge step forward, right?
Oh, absolutely. This is huge for scalability. By integrating the control electronics right there with the qubits, you can dramatically reduce the amount of external control electronics needed, which are bulky, expensive, and generate a lot of heat. It simplifies the whole architecture of the quantum computer.
So it's like they're getting rid of that whole quantum chandelier mess of wires and equipment and replacing it with something much more streamlined and elegant.
Exactly. It's a big step toward making quantum computers more practical and less intimidating.
And they're not just talking about this. They're planning to have these transistors available to customers in 2025. That's pretty soon. And it sounds like the benefits could go way beyond just quantum computing.
Yeah, absolutely. While quantum computing is definitely the most immediate application, there's also potential in other areas that deal with very low temperatures, like high-performance computing and even space technologies. Anything where you need electronics to operate reliably in extreme cold could benefit from this.
So a really fundamental advancement with the potential to ripple out into a lot of different fields. Now, SemiQon seems pretty confident about their progress, saying they're on track to achieve what we set out to do. What are some of the key milestones they've hit that give them this confidence?
So just in the past year and a half, they've done a lot. They've secured some important intellectual property, hit some key technology milestones, and importantly, they've stabilized their fabrication processes.
So they're actually able to reliably build the things they're designing.
Right. They've also shipped out their first chips to partners, which is a big step. Plus, they've created good-performing quantum dots, which are like the basic building blocks of their qubits. And now they have produced and validated the performance of these new cryo-CMOS transistors. Those are all concrete achievements that show they're moving in the right direction.
Yeah, they're walking the walk, not just talking the talk. And it seems like investors are taking notice. They just got a pretty big chunk of funding, right?
Yeah, they secured 17.5 million euros from the European Innovation Council, or EIC.
That's serious money.
It is, and it's a big vote of confidence. It takes them from being a scrappy startup to a more established company, a scale-up as they call it. The funding includes a 2.5 million euro grant, which is basically free money for research, and then another 15 million in equity funding, which will help them commercialize their tech and explore other applications.
So it's not just about building cool tech, it's about turning it into a viable business.
Right. And they're also building partnerships, like their collaboration with the University of Jyväskylä to do research and expand Finland's national research infrastructure for quantum computing.
So they're really becoming a key player in the quantum ecosystem.
Absolutely. They're also part of a consortium that just got a 3.2 million euro EIC grant to advance quantum technologies in silicon, and they're the only private company in that group. Plus, they've been featured in Forbes, which is always good publicity, and they've partnered with SDT to build a modular system for quantum computing, which is all about reducing costs and making it easier to scale up.
So it's lots of momentum and external validation, which is always a good sign.
Absolutely.
So to wrap it all up, it seems like SemiQon is carving out a pretty unique path in this race to build practical quantum computers. Their focus on silicon and their deep expertise in cryogenic electronics, that's really setting them apart.
I agree. And that new cryo-CMOS transistor, that could be a real game changer, making these quantum computers much more efficient and scalable.
So for our listeners who are always looking to stay ahead of the curve, this deep dive into SemiQon gives you a glimpse of a company that's really pushing the boundaries of what's possible in quantum computing. They're working to make it a reality, not just a sci-fi dream.
And it makes you think, right? When you look at how a seemingly small advancement, like a new type of transistor, can have such a huge impact when it's specifically designed for a challenging environment. It makes you wonder, what other technological barriers could we break through if we really focused on pushing the limits of what's possible in extreme conditions? There's a whole universe of possibilities out there.
So much to explore. Thanks for joining us, everyone. We'll see you next time on The Deep Dive.
Thanks for listening to the Nordic Venture Show. Don't forget to subscribe and stay tuned for more stories of innovation from the Nordics.